next number, the next question is check the number is Armstrong or not. So before that, what is an Armstrong? So let's say we have a number called 371. So if length of the digit, which is 3, right, which when we multiply each digit uh, with the length of the digit times, and when you add it in the result, you get 371 again. That is when you called a number is an Armstrong. So something like when you multiply each digit with the length of the the length of the number of times, like 3 into 3 into 3 plus like 7 into 7 into 7 plus 1 into 1 into 1. Okay, so right, so it's like 3 cube plus 7 cube plus 1 cube, and you get the answer 371. Then you say the number is an Armstrong. So try to implement, write the code logic for this. It's similar to the previous one which we have seen, reverse a number. So it applies, something like that. Pause the video and give a try. If not, I'm there, to tell you about this. So okay, so how we can do this? So let's say, let's think how logically we can think about it, right? So here we say that we need to have each number separately. So if we want to have each number separately, why can't we do modulus 10, right? So as we know that when you do modulus 10, right, you get the last number every time when you do it. When you do it modulus 10, you get the last number each time. So why can't we do that? So that's the one way that we can get a number for each time. And the other one is, we have to know the length of the digit, that we can know. So we have a len function. We can convert this int. So since it is a number, it will be in data type, so we have to convert into string, and we get the length of the number, right? So that is one thing. So we can get the length of the number. So after getting the length of the number, right, so what we need to do is, we have to multiply those many times, right? So in order to multiply those many times, right, so suppose this is mod, right, and from mod we get the number of digit, the number last number of digit, and you do mod star star, which is like a power. Okay, when you do star star in Python, it's like in power, and whatever be the length of the digit, right? So let's say length of the digit would be like d. Okay, or length, the digit length, for simplifying, len length. Okay, so len, and just store it. So since we need to add it, right, so we can use this operator plus, which is equal to, which means let's say this is result. Okay, this is result, and so basically if we expand this, right, it is something like this, like result is equal to result plus and this mod into length, mod into star star length. So that is what it is. In short form, we write plus equal to. So as usual in the previous video, we have to iterate it until we reach the last number. So we'll use while loop, while the number is not equal to 0. Okay, and we have to remove these numbers too, right? So after taking it out, we have to the number should remain the other digit. So for that, what we can do is, we can divide it by 10. So let's say this is the number, and we can use short form notation, something like this. And you get, when you divide it, right, divide it by 10, you get, you'll be removing this 1, right? You'll be removing this 1, and you will be having only 37. And when you iterate it, right, so you get 37, and when you mod it, you get 7, and again you'll add it to the result. You'll be doing with the length of the digit times, and you'll add it to the result, and same process continues until you get number equal to 0, right? And after getting that number, right, so the result, check the result is equal to our number. So here one thing is that we need to store our number into, we have to make a copy. So let's say this is original number. Okay, in the previous statement, just copy it, because we are editing it, the variable. So we are just overwriting our number variable by dividing it. So we have to put it in another variable and check the result with the original variable. Okay, so and you'll get the answer. So it's the simple problem. but this lays the foundation in the advanced topic actually. So yeah, so this is how you think, and this is how you approach a problem logically. So if you solve this problem without saying, then you're in a good track. If not, yeah, you're still learning it as me. So thank you guys. So code for the Armstrong. So this is the Armstrong function. So first we need to have the length of the digit. So for that I need to convert int. So the number will be in int. So I need to convert into string, and have a result variable as I equal to 0. And as I said, we are modifying the number. We need to have the original number not to check for the check for the last result equal to the original number. For that I'm storing it in another variable, and we have an while loop where a number is not equal to 0. As I said, it should be it should be iterating digit by digit, so till it comes to 0, right? So this is the while loop for that. And for digit by digit we need to remove the we need to remove the last digit. For that we need to do mod 10, and we need to apply that formula, which is mod power the length of the digit, and add it to the result. And to get iterated, we have to be removing the whatever be the reminder that have to remove, and have only the remaining digits. For that you'll be doing divided by 10, and it's on also on until it reaches 0. And later, after doing it, just compare the result variable, which is I, with the original variable, and see if it is Armstrong number or not. So I'm giving the input 371, and let's see if it is true or not. And it's true. And that's it, guys. Check with you can also check the other test cases. If it is failed, please let me know. I'll be pushing all the code related things in my GitHub. I'll be putting it in the description. You guys can check it out. Thank you, guys. Bye.